Hi everyone. So we will start at 3 p.m. Just waiting for some participants to join in. And also this is our last live session, the week 12 session. Instructions are similar in case of any doubts and queries regarding a particular problem. Sufficient time will be given to ask your doubts. First try to type in it in the chat box. If you are not comfortable with the chat box, you can use the microphone accordingly. And we will just start in 5 minutes. So it's 3-3 now. I think we should start. So let me just share my screen first. So good afternoon, everyone. My name is Musab Rafiq. I'm the course TA for this course on digital circuits that is taught by Professor Santanu Chattopadhyay of IIT Kharagpur. Myself, I'm a PhD student at the Department of Electrical Engineering at IIT Kanpur. This is the live session 12, the last session of this course. This live session will be dealing with the problems related to the microprocessor, and instructions, as I said, are similar. First I will be discussing some problems, and sufficient time will be giving after every problem. You can type it your doubts and queries in the chat box. In case you are not comfortable or you are not able to convey your doubts and queries, you can use your microphones accordingly. So let's just start with the first. Let's just first discuss this pin diagram of 8085 microprocessor. Excuse me. Let me just first admit the participant, then we can proceed, I think. So what I was saying is, last time we discussed briefly about the architecture of 8085 processor. This time I'll be just discussing briefly. I think you guys will have gone through this in your tutorials, but let me just go through this pin diagram of 8085 briefly. The microprocessor 8085 has 40 pins. They are divided into 7. They can be easily divided into 7 components. First is the address bits and the data bits. Address bits are the this A15 to A7. These are the, let me just have the pointer first. These are the most significant 8 bits of memory and input output address. And then we have the data address from AD0 to AD7. It carries the least significant 8 bit address and data bits. After that, we have control and status signals. We have 3 control signals and we have 3 status signals. They are used to identify the nature of operations. We have the 3 control signals are RD, write, and ALE. ALE stands for address latch enable. WR is the write. This signal indicates that the data on the data bus is to be written into a selected memory or input output location. And then we have the write this RD signal, which indicates the selected input, output, or memory device is to be read and is ready for accepting data available on the data bus. And for the status signals, we have 3 status signals. One is this input output memory. It is a signal used to differentiate between input output and memory operations. And when it is high, it indicates input output operation, and when it is low, it indicates the memory operation. Then we have this S1 and S0. These are the two signals used to identify the type of current operation. Then we have this power supply VSS and power supply signals, VSS and VSS, VSN and VCC. VSS is the connected to plus 5-volt power supply, and VCC is connected to plus 5-volt power supply, and VSS is connected to ground signal. Also, we have the clock, this clock signals. 3 clock signals are present: X1, X2, and clock out. This X1, X1, X2 is used to set the frequency of the internal clock register, and clock out is used as a system clock for devices connected with the microprocessor. Then we have interrupts and externally initiated signals. Interrupts are the signals generated by the external devices to request the microprocessor to perform a task. There are 5 interrupt signals. These are trap, RST 7.5, 6.5, 5.5, and 4. This INTR. Also, we have this signals, this INTA, which is the interrupt acknowledgement signal. Reset in. We have the ready, we have the hold, and we have the HLDA, which is the hold acknowledgement signal. And finally, we have the 2 serial signals, SOD and SID. SOD is the output. SOD is set and reset as per the SIM instruction, and SID is the serial input data line on which the data on this line is loaded into the accumulator whenever the RIM instruction is executed. So I have taken this picture from the source, and this was just a brief introduction towards this pin diagram of microprocessor 8085. This pin diagram and architecture, these are really important when you are dealing with this topic, that is the 8085. So before I proceed to the first question of the today's live session, let me just admit some students, then we can start. So I think we can now start with the first question of today's talk. So let me just have my pointer. So the first question asks us, the accumulator has data FFH, and so what we are asked to do is determine the state of carry flag, zero flag, and sign flag when 0h is added, and the content of accumulator is incremented. So we have to find the status of these three when these two operations are performed. So let me just do the first one. So first we have contents of accumulator are being loaded by this ff. So a is equal to ff, so we can write it as let me just correct this can write it as 1 1 1 1 1 1 1. So this is ff. So the first operation that is being done here is addition of 1. So addition of 1 to accumulator. So 1 plus 1 is 0 1, so the carry will propagate. Yeah, hi everyone. Can you please turn off your microphone, Komal? Yeah, thank you. So as you know that my PC ran into some kind of trouble, so let me just restart from question number 1. We'll just go through these questions quickly as I'll be recording them simultaneously. Okay. So uh, let me just give introduction again. So my name is Musa Rafiq. I'm a course TA for this course on digital circuits taught by Professor Shantanu Chittopadhyay of IIT Kharagpur. So today we'll be discussing this questions related to week 12 tutorial, which contains mostly dealing with the problems from microprocessor 8085. So before we proceed, let me just start with the first question, as we discussed earlier also, but let me just do a quick revision for this. So question number 1 asks us, accumulator has data FFH. Determine the state of carry 0 and sign flag when 0 1 is added and the content of accumulator is incremented. So we are given two operations. One is addition, another is increment operation. So we are just required to find the state of carry flag, 0 flag and sign flag after these two operations are done. So we have the contents of accumulator as ff, so that is 1 1 1 1 1 1, and in case of this case first tells us to add 1 to it, so we are just adding 1 to it, 0 0 0 1, and once we add it, yeah. Oh, sorry, actually no issues. Yeah, is it visible now? Okay, thanks. So let me just start again. So accumulator has data ffh, and we are required to find the state of carry z and sign flag when 0 1 is added and the content of accumulator is incremented. So case 1 is addition operation to this accumulated data, that is ff. Someone has just turned on his microphone. Can you please turn it off? Yeah, let me just check. Manish, can you please turn off your microphone? So addition of 1 to this ff. So when we add this to the contents of accumulator becomes this 0 and carry flag is set to 1, and since the number is not negative, sign flag is 0, and the operation second is the content of accumulator is incremented. So this accumulator contents get incremented by 1, so 1 1 1 1 1 becomes 0 0 0 0 0, and the carry flag in case of increment operation is unaffected, but the 0 flag will be set to 1 and sign flag will remain as 0. So the correct answer to this question is option 2. Now question number 2 is an 8085 microprocessor accesses two memory locations, 2001 hex and 2002 hex, that contain 8-bit numbers 98 hex and B1 hex respectively. The following program is executed. So what we are doing is this HL has this memory location 2001. Then we are moving the contents of the we are having this 2 1 getting loaded into this accumulator to 1x. Then we are incrementing this HL by 1, so HL becomes 2002. Then we are having this operation addm. So what is addm does is the contents of accumulator A get added to the reference date of HL pair. So accumulator contents are 00100001, that is 21, and the reference date of HLPR at memory location 2002 is, as per the question, B1. So B is 1011 and 1 is simply 1. And when you add these two, it becomes 1 plus 1 is 0, 1 gets carry, 1 0, then it's 0 0, then 1 0 0, 1 is your carry, and 1 1. So this is 1 1 0 1 0 0 1 0. So that is D2 hex. Then we are moving these contents to the memory location at 2003 because this INX got incremented, and we are required to find out the number at this memory location in base 10 system. So we will convert this D2 into this base 10 system. Simply D is 16 raised to power 1 multiplied by 13 plus 16 raised to power 0 multiplied by 2. So 16 multiplied by 13 is 208 plus 2 is 210. So the number at this location will be 210 in decimal system. So let me just stop here because we had covered up to this point, and let me just start again at question number 3. So Manish, you are turning your mic is on. Let me just mute you. Yeah, yeah, I'll repeat. Actually I had covered it in previous this session. So yeah, yeah, that's why I was going fast here. So yeah, I'll repeat it. No issues. Yeah, no issues, no issues. I'll repeat. So after addition, our result was G2. So then we are incrementing this INX H. So H was 20, HL was 2002. Now HL becomes 2002 plus 1, that is 2003. And also then we are having this contents of accumulator A at the this in this memory, that is 2003. So at 2003 we will have this D2 hex, but we need to find the number in decimal. So D2 is D2 converted into what is it? D2 converted to decimal. So 16 raised to power 1 multiplied by D is 13 plus 16 raised to power 0 multiplied by 2. 16 into 13 is simply 208 and plus 2, that is 210. So the answer is 210. So I hope your doubt is clear. Okay, thanks. So now we'll move forward to this question number 3. So the question number 3 asks us to find write a which is one of the following program correctly depicts the multiplication of two numbers stored in register B and C. So as you know, in 8085 microprocessor we don't have a direct multiplication operation. We have this addition operation. So we use this addition operation to get our multiplication. So we need, if two we have two numbers A and B, we need to add them we need to add them accumulatively B number of times or A number of times. Let's just say we'll add them cumulatively at B number of times. So if you want to multiply 2 and 3, we'll just add 2 3 number of times. So if you just want to write a program in 8085 using the addition operation to carry out this multiplication, we need let's say we have contents in register B and we have in C. So we'll just run a loop this B number of times and we'll just add C simultaneously. We just add C. So among the following operations, the correct option which depicts the multiplication of two numbers stored in register B and C is option 3. So how? So first we are just resetting this accumulator contents as 0 0. Then we are adding C. So C contains the number, one of the number. So we are just adding C. So C in the first step, C will be gets load to this accumulator. Then we are decrementing the this B, and then on the non-zero we are just moving back here again. So what this step essentially does, it adds C B number of times. So when you add C B number of times, it's simply C multiplied B multiplied by C. So this thing is our multiplication operation of two numbers stored in register B and C. Now moving forward to question number 4. So question number 4 is a theoretical question. It asks us which okay. So So we need to do the multiplication of two numbers stored in register B and C, right? So we don't have a liberty of directly using the multiplication operation in 8085. So what we do is we have this addition operation. Let's say we have this, let's say 3 multiplied by 4. So we will add this 3 to 4 number of times. So what I'm saying is 3 plus 3 plus 3 plus 3. So this 3 plus 3 plus 3 plus 3 is simply 12. So that's what we are doing here. We are first just clearing the contents of a register accumulator. Then we are adding this C. So C here is, let's just say 4, and then we are decreasing the contents of B, that is here 1. So B will become 2. Then we are going back to this here. So this will be done thrice. 4 plus 4 plus 4. So that is 12. Also we can have it like this also. If C is 3 and B is 4. So 3 plus 3 plus 3 plus 3. So that is 12. And once it becomes 0, our program will stop and we will have our result in the accumulator. Now moving forward to the question number 4, it shares what is a trap. So as we discussed earlier in the spin diagram, trap is a interrupt signal. So when we are talking about interrupts, we have two kind of interrupts. We have the hardware, and then we have the software interrupts. Among hardware interrupts, we have these two types of interrupts. One is maskable, another is non-maskable. So trap is non-maskable. At the same time, it's a hardware interrupt, and among hardware interrupt, it has the highest priority. So our three things that this trap has: it is non-maskable, it is a hardware interrupt, and it has the highest priority. So among the following options, option 2 correctly depicts the characteristic of a trap interrupt signal. Now moving forward to question number 5, it states that an interrupt in which an external device supplies its address as well as interrupt service request is which interrupt? So it's a vectored interrupt in which the answer to this question is vectored interrupt. So what is a vector interrupt? In this type of interrupts, the interrupting device directs the processor for interrupt service routine. And the maskable interrupt is an interrupt whose interrupt service can be stopped from being serviced temporarily. And non-maskable interrupt is an interrupt whose service cannot be delayed. So for this question, the answer is a vectored interrupt. Now moving forward to question number 6. So question number 6 asks us choose an incorrect statement. So we are just required to find the incorrect statement from the following regarding pin numbers of 8085 microprocessor. So it says that serial input output ports are 5 and 4 respectively. Reset out and clock are 3 and 37 respectively. Ground and VCC are 20 and 40 respectively. Interrupt and trap are 10 and 6 respectively. RST 6.5 and RST 7.5 are 7 and 8 respectively. So I had this pin diagram here which I had discussed earlier. Let me just put it out here. So it says the serial input output ports are 5 and 4 respectively. So these are 5 and 4 respectively. Reset out and clock out are 3 and 37. Reset out are 3 and 37. Clock out are 3 and 37. Ground and VCC are 20 and 40. 20 and 40. INTR and trap are 10 and 6 respectively. 10 and 6 respectively. Reset 6.5 and 7.5 are 7 and 8 respectively. They are reset 6.5 is 8 and reset 7.5 is 7. So order needs to be reversed. So option 5 is the correct answer to this question. This thing is incorrect. Reset RST 6.5 is 8 and RST 7.5 is 7. So this was the correct answer. Now the next question is, what is the length of stack pointer? So the question asks what is the length of stack pointer. So it's a theoretical question. The length of a stack pointer is 16-bit. Yeah, correct. 16-bit. So stack pointer is a 16-bit register that shows the address of top of stack memory. So the values of stack pointer get decremented by 2 on push instruction, and gets incremented by 2 in pop instruction. Now the next question is in 8085 microprocessor, which signal is used to insert wait? So in 8085 microprocessor, the signal which is used to insert wait is ready signal. So this signal, ready signal, is used to delay microprocessor read or write until a slow responding peripheral is ready to send or accept data. So the correct answer to this is ready signal. It is used to insert wait in the microprocessor. Now we have this another question. The program state word register pair is made up of A DE register pair, B BC register pair, C HR register pair, and D accumulator and flag registers. So the program status word register pair is made up of HR register pair. Sorry, not HR. It is made up of accumulator and flag registers. So the program status word is made up of accumulator and flag registers. Then we have this another question, a theoretical question. 8086 dash bit processor, a 16-bit processor, a 8-bit processor, 32-bit processor, a 64-bit processor. So 8086 is a 16-bit processor. Just give me a minute. So now question 11 asks us the trap interrupt transfers the control to location A0024X, B002CX, C003 4X, and option D 003CX. So the trap interrupt transfers the control location to the 0024X. The ISR of this trap signal is simply 200024. ISR stands for interrupt service request address. ISR address is 0024. Now we have this question number 12. It says an assembly language program is 8085 assembly language program is given below. Assume that the carry flag is initially unset. The contents of the accumulator after the execution of the following program is. So we are given this program, this, and we are just required to find out the contents of accumulator after the execution of this program. So what we'll just start with the first instruction, that is A MVI A007 hex. So the contents of A will be 07 hex. So it will be like this 000000111. So these are the contents of my accumulator. Then we have this rotate left. So rotate left operation will be performed. So the contents of our accumulator will be 0000111. Then the contents of accumulator A are moved to in B, register B. So B gets A. So that is 0000111. Then the contents of accumulator B are again A contents of accumulator are A again left shifted by 1. So A will be left shifted by 1. So 0000111. Then again left shift operation is performed. So it will be 0011100. And this thing gets now we have this operation add B. So B gets added to the contents of accumulator. So this is B was 0000111. So these two are added. So this is 0, this is 1, this is 1, this is 0, this is 1 plus 1 is 0, 1 plus 1 is 0, this is 1, so this is 1, so this is 0 1 0 0 and finally we have this right shift operation. So this will be shifted by 1. So this is 0 1 0 1 0 0 0. So this is 0 0, right shift 0 0 1 0, and then we have 0 0 1 1. So this thing is 2 3 in hex. So the contents of the accumulator after the execution of the following program is 23x. Someone has requested to join the meet. Let me just admit the person. Now moving forward to the next question. Question number 13. So the question number 13 asks us, what are the contents of accumulator after the execution of following instructions? So first we have this MVI B7X, then we have this OR of this thing with the OR operation, and then we have this rotate left. So A will be B7, B is simply 11, so B will be 1 0 1 1, and 7 will be 0 1 1 1. Then we have OR operation of A with itself, that is simply B7. So when we do an OR of a number with itself, so it is the number itself, so it is A, simply A. So after OR operation it will be simply A, and then we have this RAL moving towards the left. So one thing we should note here, once we did this OR operation, the carry flag will be remain as 0, and we have this RAL that is rotated through carry, rotated left through rotated accumulator left through carry, this RAL rotated accumulator through left rotated accumulator left through carry. So this thing will propagate like this after this RAL. So this 0 will go here, and 1 will go to the carry flag. So this will be 0 1 1 0 1 1 1 0. So this thing is 6, and this thing is 8 plus 4 is 12, 12 plus 2 is 14, that is E, 14 is E. So after the execution of this program, my contents of the accumulator will be 6E hex. So the answer to this question is, let me just write here the answer, 6E hex. So in case of any doubts and queries, please type it in the chat box. So there are no doubts, we can just move to the last question of today's talk. So since our session got interrupted in between, I don't know whether we'll have the recording of the first 10 minutes of the session. So what I'll be doing, I'll be just repeating the pin diagram thing and first two questions again, and then we will close the session. So this is the last question of today's session, but I'll be just repeating the first three, this pin diagram and first two questions, because my this laptop got restarted midway during the session. I don't know whether I'm having that recording or not. So for that purpose of the recording, I'll be just repeating those two questions again. So let me just first discuss the final problem. So the final problem of today's live session is MVI, find the contents of accumulator for after the execution of the following program. First we load the contents of A with this F0H, then we are having this OR immediate, then we are having the XOR immediate. So what we are doing here is we have this contents of A getting loaded by F0, F0. So this F0 is simply 1 1 1 1 and 0 0 0 0. Then we are having an OR operation, ORI. So ORI FF with the contents of accumulator. So ORI FF is 1 1 1 1 1 1 1 1. So this thing is OR with 1 1 1 1 0 0 0 0 0, this thing. So after you do then OR operation with this, it is this. So once you do OR of 1 with 0, it's this thing becomes 1 1 1. So this is FF hex. So after the OR operation of FF with F0, our result is FF. Now, and this thing is in our accumulator. Now after this, we are having this XOR operation, XRI F0 with the contents of accumulator. F0 is simply 1 1 1 1 0 0 0 0 0. It's XORed with 1 1 1 1 1 1 1 1. So when you XOR 1 with 0, it's 1 1 with 0 with 1 1 with 0 with 1 1 with 0 with 1. And when you XOR 1 1 1 1 1 with 1 1 1 1 1, it becomes 0 0 0 0 0. So my content of accumulator will be 0 F hex. So after the execution of the following program, my contents of the accumulator are 0f hex. So this was the last question, but as you know, my this our session got interrupted midway. I'll just repeat this thing, this pin diagram and first two questions. Then we can close the session. So I was just, as I said earlier, this pin diagram and the architecture are important when we are discussing microprocessor 8085. So the pin diagram, pin number of pins of my 8085 processor are 40, as you can see. So this pin diagram of 8085 can be divided into seven segments. First is this data and address bus. Data and address bus. So address bus are this A15 to A8. It contains the most significant 8 bits of memory and input output address. Then we have this data address from this AD07 to AD0. It contains the least significant 8-bit address and data bus. This was the first component. Then we have the second component, that are control and status signals. There are three control signals. These are RD, write, and ALE. ALE stands for arithmetic logic enable. It is the positive going pulse generated when a new operation is started by the microprocessor. When the pulse goes high, it indicates address. When the pulse goes down, it indicates data. Then we have this write signal. This signal indicates that the data on the data bus is to be written and into a selected memory or input output location. Then we have this RD signal. It indicates the selected input output memory device is to be read and is ready for accepting data and available on the data bus. These were the three. This was the control and status signals. Then we have the three status signals. Control over this RD, write, and ALE. The three status signals are input output memory, S1 and S0. S1 and S0 signals are used to identify the type of current operation, while this input output is used to differentiate between input output and memory operations. When it is high, it indicates input output operation, and when it is low, it indicates memory operation. Then we have the number three is our power supply. These are the two signals, VSS and VCC. VCC indicates plus 5-volt power supply and VSS indicates ground. Then our number 4 segment is clock. We have three clock signals, X1, X2 and clock out. X1 and X2 are used to set frequency of the internal registers. And we have this clock out used as a system clock for devices connected with the microprocessor. Then we have number 5 are interrupts, and this is number 6. One was data bus, address bus, 2 was control signal, 3 was 4 was power supply, and then we have this interrupt and externally initiated signals. Interrupts and externally initiated signals. There are 5 interrupt signals. These are RST 7.5, 6.5, 5.5 and interrupt. And then we have trap. As we saw in one of the questions, we found out that this trap has the highest priority among the interrupt signals, and it's most non-maskable and are the hardware interrupts. And also we have the external instance signals like INTA, which is the interrupt acknowledgement signal. Reset in is used to microprocessor by setting the program counter to 0. Then we have this reset out. This signal is used to reset all the connected device when the microprocessor reset. We have the release signal, which is always used in introduce a delay. Then we have this hold signal. This signal indicates that another master is requesting the use of address and data. Then this was all. And also we have two serial signals. These are SID and SOD. SOD is the output. SOD is the set and reset as specified the SIM instruction, and SID is the serial input data line. It is the data on this line is loaded into accumulator whenever the RIM instruction is executed. So this picture, this was idea about brief idea about pin diagram of 808 microprocessor. The image was taken up from this source. Now let me just revise these question 1 and 2, then we can close this today's session. So question 1 is accumulator has data ffx, determine the state of carry flag, z flag and sign flag of when 01 h is added and the content of accumulator is incremented. So when 01 is added to ffx, so it becomes when we add this one to this, it becomes 000 and carry gets propagated and this carry flag is set to 1. Sign flag remains 0 because number is non-negative, and 0 flag is 1 as the contents of accumulator are 0. Next operation is the content of accumulator is incremented. So the contents of accumulator is incremented. So once we have this increment operation, the main difference between this addition of 1 and this increment of 1 is carry flag remains unaffected. So when we add the increment this accumulator ff having this ff by 1, it gets back to this 00000. So the 0 flag will be set to 1 and sign flag will remain as 0 and carry will remain same as previous state. So option 2 was correct option to this question. And then we have this question number 2, which has this bunch of program, and we are required to find the number stored at the memory location. So first this HL register gets loaded by this 20 and 001. Then A gets loaded by 21 hex like here, and then we increment this HLPR. So 2001 becomes 2002, and then we add this data, and then we have this instruction addm. What it does is, so the contents of accumulator get addressed to the reference data of HLPR. HLPR is here 2002, so at 200 data we have is B1 hex. So this is B1. The B1 gets added to this 21 hex. So after the addition of B1 to 21 hex, we have our result is D2 hex, which gets stored to the accumulator. After the add operation, this we again increment our this HLPR, so it becomes 2002 becomes 2003, and the contents of accumulator are moved to this memory location 2003. And finally, we have this halt, which will stop our program. So after the execution, we have the answer D2 in our memory location. So D2 in decimal system will be 16 raised to power 1 multiplied by 13 plus 16 raised to power 0 multiplied by 2. 16 multiplied by 13 is 208 plus 2 is 210. So my answer will be 210 in decimal. So this was all for today's session. So Komal has written doubt in assignment question. It is assignment 12 or 11? Uh, the live session one or the portal one? Yeah, yeah. Did you check the solution? Question number, let me just open the portal. Question number 11. Question number 8, assignment. Yeah, this one. Okay. So what are we having in this will be let me just do it myself first, then we can have. So first we are loading this 1 2 3. So contents of B will be 1 2 3, right? So this is 1 2 3 hex. So 1 2 3 hex will be 16 square is 256 plus 16 raised to power minus 32 plus 3 is 3. So let me just do it, and in that way you can also have a look at this. Just wait a minute. Are you able to see the screen? Okay, let me just share the screen first. Now I think you'll be able to see it or no. So this question, na? Okay, let's do it simultaneously. So we have this B, add 0 1 3x BC pair, right? 0 1 2 3. So this thing in decimal will be 16 square multiplied by 1 plus 16 multiplied by 2 plus 3, correct? No, I'm not calculating for t states. I'm just converting to decimal number. So this is 256 plus 32 plus 3. I may be wrong, but let's just check. Okay, 291, right? So 291, loop will run 291 times. So let's just add these things. 6 plus 4 is 10, 10 plus 4 is 10 plus 4 is 14, 14 plus 10 is 24. So it will be 24 multiplied by 291 minus 3. So 291 multiplied by 24 minus 3. It's 6981, right? 6981 plus 10. How much is that? 6981 plus 10. 6991. So our answer will be 6991 divided by 5 into 10 to the power 6. Right? Divided by 5. So it will be 1398 into 10 to the power minus 6. So it will be 1398 microseconds, like this. Answer is given as option A. So let me just check. Let me just check their solution. What have they done? They must have given A, but let me just check their solution. Maybe we might be wrong. 698 1.2. What is 1 divided by 5 megahertz? That is zero point 0.2. 1398.2 microseconds. These both options are correct. If you just look at it, both of them are correct. It's quite funny. I just write them a mail. They will just correct it. Both of them are correct. They are the same thing. Some might have given option A, some might have given C. See, in their solution also they have written 1398.2 microseconds. That's here. And then, yeah. Yeah, just write them. They'll just correct it. Yeah, you guys have to write on mail. We are not connected with them. We have a different team. Yeah, last time also some of the problems were having this different answers. They correct. Mm. Ah, okay, but you, you write a mail to them in case they have some other options. They'll just tell you. Just write a mail. simply. So that was all for today's session, and in fact that was all for the course. So thank you guys for joining. This was my first experience related to teaching. I hope I did a justice with this course. So let's just hope we'll meet again with some different course in future, and all the best for your exams and all the best for your future. So thank you guys. Thank you so much. So Vivek, can you please ask your what is your doubt? Everything will be uploaded in the swim portal. You'll get the recording, you'll get the solutions, you'll get the questions. Everything is uploaded. So thank you guys for joining. Let me just close the session. Thank you.